We can measure an object's speed by determining the time it takes to travel a certain distance. Remember that speed is the rate at which we travel a distance. For example, we can measure the speed of a rabbit running. In order to calculate the speed, we need to know the distance travelled and the time taken. The speed is then equal to the distance divided by time. So for the distance, we can measure how far something has travelled in a certain time, or here we determine a distance to travel in advance. We can measure the time using a stopwatch, and we can either stop at a certain time or after the predetermined distance is completed. So here we use a stopwatch to record the time between the rabbit starting and finishing its run. The distance is 4 metres, and the time taken is 1.6 seconds, so the speed is equal to 2.5 metres per second. But what happens if the speed of the rabbit is changing? This measurement just gives us the average speed. Breaking the timings up across smaller distances can show how the speed is varying. So now we're breaking the rabbit's journey up into 3 even parts with the same distances. Notice how the rabbit slows down during its run. We record a time for each individual distance, and we can see that the differences between them are increasing. So the time between each is longer. This tells us that the speed is different, as speed is equal to distance over time. If the distance is the same, then a different time means there must also be a different speed. If we measure more intervals, then that tells us more about the speed. But we also need more precision. You may be asked in an exam to design experiments for calculating speed and what it is that you'll need to be measuring. But is there a more accurate way of measuring the time? Video recordings from high-speed cameras can help give more accurate readings for times. A high-speed camera measures more frames or images per second, so there's more precision for timing of the image. For example, consider the end of a Formula 1 race. It would be inaccurate to record this time by eye as the car is too fast. So it would be too hard to accurately see when it crosses the line at this speed. A camera helps this, as we can look back at the footage and view it frame by frame to match the frame where the car crosses the line to a timestamp. This method is commonly used for photo finishes. So are there any other ways we can accurately record the time in real time? Light gates can be used to automatically record the time an object travels through them. So a light gate has sensors which can detect when the beams of light are blocked as an object passes through them. It then records the exact time that this happens. For example, we could use light gates with a toy car on a track and project the gate across the finish line. In your exams, you may be asked to critique experiments for how accurately they can measure speed and suggest ways of improving the accuracy, such as using light gates. So how can we measure speeds by recording distances instead of times? And how can we visualize these distances? Ticker timers imprint dots on paper at a constant rate. So in the example seen here, the same amount of time has passed between each dot being imprinted. We can determine the speed that the paper moves through the timer using the distance between the dots. So as you can see, the distance between the dots is changing. As the dots are further apart, this tells us that the paper is speeding up, as more distance is covered in each interval. We can calculate the speed of each interval by dividing the distance covered by the time period. So what other technology can we use to measure speeds? Speed cameras can be used to quickly determine the speeds that vehicles travel at. Speed cameras are used for safety purposes, to make sure cars aren't driving too fast. Fixed cameras work by recording markings on the ground and measuring how long a car takes to cover all of them up. Speed guns work by shooting light pulses and measuring the difference in time between the received reflected pulses. You don't need to be able to recall how speed cameras work for your exams, but you should be able to interpret how the measurements they perform lead to a calculation of speed.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy-to-follow videos, and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!